Hey guys, good evening. I welcome everybody again to our today's discussion. I hope I'm pretty much audible as well as visible to everybody. Hey guys, good evening. Yep, cool. Okay, so as always, it's pretty much a live session, guys. So we'll keep on interacting. Let's wait for a minute or two to let others also join in. Okay, I think we can start. So should be fine, and I think we're good to start. Okay, so today we are going to discuss on one of the important pointers of any data science use cases. So we have been discussing around the problem statements. So in our previous discussion, we discussed about a lot of problem statements and how to coin out a problem statement. But again, there is something called as very common business problems. So we also deal with very specific problems when we try to solve a specific use case in any industry, and also on top of that, what could be a potential business solution for those common problems. That is pretty much what we are going to discuss today. That is what our agenda. So let's try to understand what do we mean by common problems or common challenges which we generally face the moment we try to solve any data science problem. Think about it, guys. So when we talk about data science, the very first thing which comes in our mind is data, right? And there is always a challenge around data. So in academics, while you are in the learning phase, you might see that you might not even encounter this problem, to be honest, because what happens generally, you are given the Excel files or the CSV files on which you are expected to solve the business problem. But in industry, as I've said, the data is never readily available, right? So we talk about maybe the limitation in what we are looking at. We are looking at some XYZ features and some ABC features are available in my data set. So the information which I'm looking at, that is not available. So unavailability of my data, that is one of a very potential challenge which every industry, every case study faces. Availability of my data, right? And again, when I say availability of my data, there are a lot of further sub challenges and how we can rectify that. Also, we will be discussing around that area. But when I say availability issues, so we always look at, is the data not available from the source itself? Or is there any differences in the requirement and the data which is available to us for processing? Or the data which is there with us, is it trustworthy? Can we rely on that data? Can we expect good analytical results once we try to process those data? So those are some really challenging questions which always haunts a data science personnel, and then we always look forward to solve these very common challenges over my data that we come across. So first very potential and very common problem we face in any business is unavailability of my data. So that is where we're going to be talking about the potential business solutions towards this problem, unavailability of my data. How can we still tackle this with some smart understanding of my environment and all that? So we're going to be looking into that. And second, we have also seen the overabundance of data. So you need ABC and you have A, B, C, D, E, F, G, H, I, J, K, L, and you have almost every fancy thing available with you. So yes, when I say unavailability, at the same time, overabundance of my data is also a challenge. And we're going to be looking at how exactly we're going to be solving those basic data problems in a day-to-day solutions of my business. So that is pretty much what I am intended to cover in this session, guys. So we will be taking about these one by one. And as always, you know, it's pretty much a live session, so I'm more than happy to take up your own questions as well. So try to put forward your questions, anything in general also if you want to talk, and more than happy to take it. So I'm monitoring the chat, guys. So feel free to reach out and do mention your questions, the one which you want to discuss on. Cool. So with this, let's get started. Before anything, you know, my name is Arpit Jain, and data science is my passion. And I really like sharing my expertise with people, and that is the reason why I'm here with you all. Technically, I have been around the data science industry for quite some time, a number of years, solving multiple problem statements in different areas. And along with this, I'm also a motivational speaker. So I do talk to students regarding their career, jobs, placements, and everything. So if you have any concerns, anything regarding that area as well, please feel free to reach out so we can always talk. Cool. So with this, let's get started for today's agenda. So our prime agenda, the potential business solutions for our common data problems. So for any data science use case, so when I'm trying to solve any data science use case, irrespective of my industry, I'm not least bothered about my industry in this case. I'm just talking about the problem statement which I'm trying to solve. So the very first problem which we always face is unavailability of data. And in this unavailability of my data, what we see is maybe from source itself there is a fault, or the data which we have is not trustworthy, or the data which we have, it's not in a usable format. There could be n number of challenges which can be revolving around the basic data what we're going to look at, right? So unavailability of data has a prime reason that the data which we are looking at might not be a good data, right? So who defines this goodness of a data, and how do we know that, okay, this data is good and that data is not good for me, right? As simple as a very simple question. How do we get to know this, right? And that we're going to be discussing these challenges. So these are very practical challenges which every data science personnel faces. So the moment I start solving a problem statement, suppose my problem statement is identifying fraud or no fraud. So that's my problem statement, right? And in this problem statement, suppose from the data perspective, I start looking at theoretically what makes sense is maybe user demographics. We talk about transaction level information. And whatnot. Do you think information like something on how India is performing in World Cup, do you think this is relevant here? No. So I still have this data mapped to the bank somehow, but this data is not useful. So is this data trustworthy? Theoretically, we can see no. So that is where again the problem comes. Even if you have abundant of data, so how good my data is, that is also very important. So that is where we will look into this, how to solve this problem statement. So how to identify which data is useful for me. That is also a very major challenge which we always face. That is what with our agenda we will be moving towards. So let's get started on this one by one. But before that, as always, let's start with something fresh. So maybe stories are just data with a soul. A very famous quote. So yes, so stories are just the data with a soul. So whenever we talk about any storyline, it has some backing of the relevant data in the background. I'm not talking about a fairy tale Disney story. Even that is backed by some data eventually. But I'm going to talk about a business storyline. So I say that, okay, the business got started in 2010 and with this and this capital, this eventually, with this liquid money, and that is the investment, and that is where the product lines got started, and the product got launched into the place, and then with this we got this customer feedback and my user sale performance records, my target pricing and everything. So all the data points eventually gets stitched together to build up a story. And we're trying to justify, we're trying to make some sense out of this business with the data backlines which we are talking about. So that is where we always say, maybe stories are just data with a soul, right? So we always try to link data with some or the other meaningful words, and that is where we are trying to understand how data can put some relevancy to my respective business stories we are going to talk about. So how it is going to play an important role, that is again very important thing to understand. For the day, problem statement, and then how we're going to be looking at each respective issues which can be used to solve our day-to-day data challenges or the common challenges which we look at, right? But before that, just a quick recap on the problem statement. So we have studied in the simplest form, a problem statement defines the pain point you hope to solve or the impact you would hope to make with your work, right? So in the simplest form, we talk about the problem statement, which is nothing but a pain point which I am hoping to solve for the business. And this pain point could be anything. So identify or solve the pain point or the impact which I would like to have on my work. That is where the problem statement comes into picture. So this statement should be clear, concise, and define a measurable outcome. So we are trying to look into the impact which we are going to have on the business, and it is going to define the pain point from the problem statement. So this statement It should be clear, concise, and define a measurable outcome. Ultimately, it's the question, what is the problem that you are trying to solve? So my end objective is to understand the pain point, which ultimately is going to be solved by this problem statement. So I'm trying to understand what is my pain point. It should answer the question, what is the problem that you're trying to solve? And creating a problem statement obviously is an iterative process. So I cannot just simply coin the problem statement the way I'm going to get an issue. It's a pure iterative process. So we need to understand the steps involved in the background. So we need to keep on discussing with the right set of people. And for that, as we have discussed, we do not mandatorily need to have a domain knowledge. But yes, obviously domain knowledge will play an important role. If you have the domain knowledge, obviously you will be able to understand the problem statement in a better way. But being into data science, as you know, you can still work in an unknown domain. And if that is the case, you can still pretty much apply the techniques and the rules and talk to the right set of people, understand the regularity of the work, and then eventually you should be able to understand the problem statement there as well. Right. So now let's move towards the common data problems that we have been looking at. Right. And then we'll also be discussing about the potential solutions across these common data problems. The very first problem which we have seen in the industry is not having enough data. Right. And when I say not having enough data, it becomes a problem. And it's a very big problem, because if you do not have enough data, then logic of generalizing this trend for any of your training ML algorithms would become a challenge, because you might not have the sufficient data points to generalize this logic or the patterns. So yes, if there is not enough data, it becomes a challenge to have the right set of training done on the algorithms. And yes, if the data is limited, it can obviously lead to my inaccurate and the inefficient outputs. You can see this. So it will lead to my inaccurate and my inefficient outputs, costing the company a lot of time and resources. So the moment I'm going to look at the problem statement here, the moment I'm going to start looking at the data, and if the data itself is limited and I'm trying to work around that, it is going to cost the company a lot, because ultimately you're still trying to solve the problem with the limited information you have, and which eventually might not result in the true information which is expected. So not having enough data is a very problematic situation, where we can be led towards an inaccurate and the inefficient outputs. And this eventually will make sure that the generalization of my patterns is not getting fulfilled to the requirement need. Right? And how to treat this? So this we have understood, yes, we have realized not having a data is a challenge, it's a problem. I mean, obviously it is going to lead to some inaccurate results and some inefficient outputs. And obviously it is not going to give me enough information that why this problem is happening. Why this is the reason for this, right? So, and what will be something in the future? So because I do not know the right set of pattern to relate my X with the Y's. So what could be the potential solution? Ultimately, when I say I do not have the data, the solution is what? Get the data. So ultimately, if I do not have the data, my end objective for this solution will always be revolving around get the data, right? I'm saying that yes, if I do not have the data and I still need to solve this problem, I need to have the data. Whether I'm going to some randomly put some garbage, obviously this will have some own pros and cons, or I'm going to some look forward to some other source, maybe try some other sources or something like that. But the end logical solution towards this problem is you have to get the data. So first potential solution for this is we're going to talk about generation. We're going to say we have to generate my data, right? And obviously this generation of data is very vast. It's itself, there's a lot of logics involved in this. Think about it. The moment I have a data set and the data itself is not sufficient, yes, I can go for random generation of my data. And then for this, we have multiple methods of generation. I can do a simple random generation, or I can do some sampling, and I can perform some stratified sampling, stratified generation, or we can also do custom generations, volunteer generations, lot many methods. So ultimately, my still end objective is to have the additional data points for my entire process. And how that data point is getting generated, whether it is getting generated from a single methodology, which is like a random part, or custom based method, or having some smart imputations like stratified generations. Data. And obviously each of these methods will have its own pros and cons. When I say about the random generation could be anything. Suppose my data point says something like this. I have an Excel file. I have columns like A, B, C, D. And it's like 10, 12, 13, 14. And this is like 100, 1, 100, 3, 100, 4, 100, 5. And this is like, say, X1, X2, X3, X4, and something like this. Okay. Now, I only have 4 records here, 4 samples. Now, suppose I'm going to artificially generate the data points with random generation, maybe add 10 more data points. So this newly generated data here, it could have any value in A. Suppose the newly generated data will have values like 2000, 3000, something like this, and B got changed to 0.34, 0.78, something like this. Some random generation is happening. So I do not have any control in what data. And obviously, you can obviously understand the moment I'm going to generate this data randomly, I am going to lose out some trend and I'm going to add some noise in my data eventually. So that being said, obviously generation the data randomly is going to create some troubles. And that is where we have some custom level generations. So we always mark some boundaries and we mark some ranges. That's where custom sampling, custom generation, or my stratified generations for each samples, equal representations from each samples would come into picture. But still the end objective is I am artificially generating the data points to a number requirement. And yes, any artificial generation will have some or the other challenges. It is never a true representation. It is always I would say an expected close to real representation. That's what we can say this as. So one of the prime solution is generation of my data. Next, then we talk about data augmentation. Data augmentation is again one of the very standard. Now I'm going to look at to increase the diversity of the data available for training models without having to collect new data. So this step involves multiple things. So first, again, look from the rows as well as from the columns perspective. So for rows, in data augmentation, we can artificially generate the data points. Lot of smart techniques are available for this. There is one of the smart techniques called as SMOT, and it uses the concept of KNN inside. We're going to be reading KNN with time. So it is going to synthetically generate the newer data points from a minority pointers. So my minority is my entire data set. So I'm going to artificially generate my data points considering the essence of my minority classes. And from the columns perspective, you can look at the feature engineering which is happening. It's more like feature engineered columns. So in this case, we say, suppose I have the feature sets which is like columns A, B, C, D, E, F, right? Now I'm going to generate, so I have the columns right now which is A, B, C, D. Data augmentation strictly says no data collection. So from the available A, B, and C and D, we can probably generate a new column E, A plus B divided by C. We can generate a new column F, which is nothing but C multiplied by D divided by A plus B. And basically what I'm doing, I'm generating new data points which is having some or the other essence of my available features. And how to identify this? When I say A, B, C, and D, now I'm going to look at the value pointers which is used for this part. A, B, C, and D. I have the columns A, B, C, and D, and I'm generating the new pointers E and F by certain formulas. So the question here is, how do I get to know that this is what I have to implement? This is what I have to do. So to get an E, I can do A plus B by C. Is it always true? Who gives us this information? How do we get this? And that is where the subject matter experts comes into picture. That is where the people who are directly working with the business from a technical perspective, not from a data side, they are the right people to have this information, that how each of these KPIs or each of these respective feature sets are interacting internally. That is where we might get some formulas and we can generate some new augmented data points. So another potential solution for not enough data is towards data augmentation. Obviously, it will also have its own pros and cons, but the end objective is, when I say I do not have a data, I intend to have the data now. My objective is to have the data. Another potential solution is we have to avoid overfitting. So what generally happens in the lower dimension data sets, the likelihood of overfitting increases automatically. What is an overfitting? First of all, let's try to understand. Suppose this is my data set. I have, say, feature 1 here and feature 2 here. And this is how the points are coming up. Okay. So if I'm trying to capture the trend between my F1 and F2, so basically drawing a linear relationship line, so that line will some or the other way look something like this. I'm just putting a new color to this. So it might look something like this. Correct? But what happens in a overfitting case? The same line which will be looking something like this. Can you see this? So instead of generalizing this trend, what just happened? It tries to capture every single information. And when it does this, it is not able to generalize the trend. This will be very bad to predict what is going to happen in future. Based on this, it can go here, it can go here, it can go here. It has no clarity because the graph has been changing quite a lot without having any significant pattern for each of my pointers here. So that is what the problem of overfitting says. We are becoming too rigid and we are trying to capture every single information which is not required to generalize. And that will happen if we do not have enough data points. And if we do not have enough data points, that means that I am not able to generalize my trend. And when I'm not able to generalize my trend, that means I will not be able to capture the holistic view of my appearances here. Rather, we will be becoming too rigid and stringent to capture every single information, which eventually might be good for training time. But the moment you're going to test it on some newer data set, that is where it will fall drastically. So yes, for this, we are supposed to avoid overfitting. Again, a potential solution. So try to always avoid overfitting. And this will always be there for a smaller data set. And overfitting again is a modeling error that occurs when a function is too closely aligned to a limited set of data pointers. Great. So that's about my first potential type of data problem, common data problem. Second is also when we talk about too much of data, even this is a problem. So sometimes we discuss that we do not have enough data, but it's also a problem with having too much of data. Even that is a problem. And always remember that having more data does not mean that your model will produce accurate outputs. Data, how is the quality of data? What is the relevancy of data? How this can be used for business purpose, usefulness? All of these things become very important to understand how we can leverage the information which is there available. And also, the moment I have too much of information, it becomes a problem from a computational point of view as well. Computational power, time taken also becomes a very crucial discussion pointers for my overall output parts. So for this, having too much of data will also create troubles. And the moment I have too much of data, factors such as computational power, time taken, all become very crucial pointers to discuss. So again, as I've said, having enough data, having too much of data, having more data does not always guarantee a good model. Rather, the usefulness of it, the relevancy of it, that's what we have to look at. So let's try to understand what are the potential solutions for this. The first is P value or the probability value. So P value is the probability that results from your sample data occurred by chance. Therefore, a low P value is good. So we always say hypothesis testing. There is something called as hypothesis testing. By that, we mean if the data, whatever that I have, the P value, it tries to identify how good those pointers are to justify what is happening in my target. So whatever my target feature is, how good that feature is able to justify the reason of that happening. Is it happening by chance or is it happening for a fact? So lower the P value, that means lower it is happening by chance, or that means it is better, it is good for my discussion points. So it is not happening by chance, it is happening by a fact. And the P value also depends on the size of the data being tested. The larger the sample size, smaller the P value, because it is going to generalize my trend. And if also the sample size is large, there is a high chance of finding a significant relationship, if there is anything. More smartly generalize that trend and eventually going to lose out on the random errors which is going to happen in the training process. So P value, one of the very strong metrics which is going to be chosen to avoid this very classic problem of too much of data. So P value, just to tell you again, so P value is nothing but a probability value which is going to result from the sample of my data occurred by chance. So basically, if any pattern, any reasoning which is happening by chance, that is going to increase my probability value. But from a true perspective, we are not looking at the information which is happening by chance. Rather, we need to have a concrete proof. Okay, this is the reason why it is happening. So lower the P value, better my patterns are. And the P value size, P value depends on the size of the data. And obviously, if the data size is smaller, that means I have higher P value. Or if I have the larger data set, the P value will eventually keep on decreasing. That means I'm losing out on my random errors, which is happening as well. Right? So that's pretty much about my P value. The second is the computational power. There are two logics here. When I say I have too much of data, so the question is that data actually good? Or if it is good, do I have the competency to process it? Do I have the right set of infra to process it? So all of these informations become a very crucial pointers for me here. So computational power, it's again talking about the infra availability, my competency to process the abundant data I have in terms of solving the data problem. So computational power is nothing but the ability of a computer or any infra machine to perform the certain task with speed and accuracy. If my machine is of say 16 GB of RAM, and if I start processing data which is of 50 GB, obviously my system will get stuck. It won't be able to process it, start giving some errors. Although I have abundant of data, but that data is not of any use if my infra is not capable enough to cater that information. So what can we do in this case? Either we have to enhance my computational power, either I have to upgrade the infra on which I'm going to work on, or we have to reduce it to samples. We cannot use the entire data set, because as simple as that, if my system allows me to solve the maximum of 16 GB of data, I cannot process 50 GB of data. I can only process 16 GB, not more than that. So I have to make sure that I have to limit the availability of my data by taking some samples. So either I upgrade my infrastructure to cater the higher demand of data, which will involve a lot of financial parts there. So whether I'm going to take a physical machine or whether I'm going to take the services online from a cloud service, that depends. But the end objective is, if I have to process the enormous data, I need to have the infrastructure. So computational power is going to play a very crucial role here. And if we are not going to do in that direction, so that abundant data is of no use, I have to reduce it to samples, to smaller chunks, so that it can be consumed. And obviously, yes, there will be its own challenges. The moment I talk about samples, I am losing out data. And losing the data is anyway at any cost not beneficial, but we still talk about identifying the right methodologies to still look forward to right set of data which can be chosen without having major loss in the model performance. So that's again a potential solution for too much of data. But even apart from this, there are certain questions which are still very important to answer. First is, what's my desired time frame? So if I'm solving a business problem, what is the time frame I'm looking at? Look at this example. So suppose if I'm trying to predict what will happen in the next 5 years. So having data only worth of last 1 year is obviously not going to be efficient enough, because I say that I need to predict for the next 5 years, but for that I only have information for 1 year. So obviously 1 year of trend might not be the efficient solution to predict for the next 5 years. Yeah, maybe with that 1 year of information I can predict for next 1 month, but the time frame of 1 year extrapolated to 5 years is obviously unrealistic, because we are losing out on season level changes, year level changes. So all of this, we are completely losing out on the track. So this is something we have to always keep in mind. So what is my time frame? What are we going to look at, and what are we expected to solve from the available information? And you will also need a minimum of 5 years, and you need to ensure that there is not a lot of missing data to produce the accurate results. Yes. So at least to predict for the next 5 years, I need to look at the past 5 years of history. And it's not always about having a historical data, but also about ensuring of data quality. By that, I mean not having too much of missing data, one of the pointers, and a lot of others also we will read with time. So how good my data is, I need to ensure that. And if I need to predict something for the 5 years of time frame, so yes, I need to make sure that I am also talking about from a data perspective that I do have something similar information available to ensure there is no layovers on this. Another very important question is about what is the granularity of my data. Again, a very important question. What granularity level I'm going to look at? So suppose when I say that I need an year worth of data. So does my data correspond to that? Is my data is in days, weeks, or months? Suppose I say I have 1 year of data. So 1 year of data can have 12 rows, which is per month, can have 52 rows per week, can have 365 rows per day, can have 365 cross 24 rows per hour, and 365 cross 24 cross 60 rows per minute. So likewise, my granularity of information is getting changed. So by 1 year, I have to understand what granularity of information are we going to talk about. And that is going to change the entire hypothesis. That is going to change my entire result sets. So an year worth of data could be 365 points or 365 rows if it's on per day, or 52 points if it is per week, or 12 points if it is per month. And if I go back, if I go drilling down more, like per hour, per minute, per second, likewise, I'm keep on increasing my data points. And all are equally valid. It's not like this month level is not valid, this week is not valid, the second is not valid. All are equally valid. However, it is about our problem at hand which we have to solve and what we require. Right? So always it is mandatory to understand my requirement. So first, I need to understand the time frame on which I'm trying to solve the problem. What is the desired time frame? I cannot predict 5 years in future with having 1 year of data. And also when I say about 5 years in future or some X years, what is the granularity of information? What if I'm trying to solve, if I'm trying to get the trend per week, I cannot solve this by if I'm having a data of per month. And if I'm looking at trend per second, per day data cannot help it. So I need to make sure that the data is adhering to the requirement of my problem statement. So again, a very potential problem. What is my granularity of my data, which can also lead to your problem? So always we have to make sure that it is adhering to our requirement. Cool. So with this, guys, these are my prominent questions. This is what I wanted to cover today. So I hope you got a fair sense, like what are the very prominent data level issues or challenges which we face day in and day out, and what are some potential business solutions around those areas? How can we rectify these? So this, any questions, anything which you want to discuss, guys, please let me know. I'm more than happy to discuss, so we can take up your questions. Or if we are good, then we can wrap it up. I can only say thank you so much for being patient and listening to me. So with this, we have also identified what could be the potential business solutions for common business data problems which we have. So with this, we're done, guys. So thank you so much. See you in the next video, where again we will come up with something very interesting. So more towards the key metrics and the drivers for our problem solution. So we're going to be discussing around that. Thank you so much, guys.